Hello everyone. This is a project I'm doing for an Instructable. I'll put all the details on the Instructable once I've written it up. Basically, it's another web page and server on the ESP. What is it? 2866. And I'm controlling the intelligent LEDs. I've made a web page, put a nice little LED on here, and at the moment it's connected to my local network. With the local network, any device with a web browser can actually connect to the ESP 2866 because it's actually connected to my local network at the moment. So I've done this little control panel so we can actually alter the red. It doesn't actually set the colour on the LEDs until I let go of the slider, so you can just, it'd be sending too many commands if it did it now, basically. So when I let go, it should light up the LEDs this colour. So turn it down, turn it up. This is the brightness, so I can turn the brightness down. And I've made a web page to try and emulate these four sliders. So if we put some green on, turn it a bit yellow. It's a bit bright, that, so just turn it down a bit. Add a bit of blue, makes it a lot whiter. Let's get rid of the green and the red. So we've got just the blue, but basically you can choose whatever colour you want, and it's using a 0 to 255 value on each colour. So if we turn all them off, and also what I've done is I've done this auto sequence button here. Basically what this button will do, it'll be run through the greens 5 times, blue times 5 times, red 5 times. So basically we're going to get 125 different colours here. So if I run that, you'll see it changing through. What I can turn the colour down while it's doing that. Turn the brightness, shall I say. So we'll let it do that 125 times. I'm just using a breadboard. This is a logic converter. It converts the 3 volts from the I'm just going to call it ESP for now. So from the ESP, well, the ESP runs on 3.3 volts, and so the logic from that is 3.3, and I'm using one of these little power supplies which gives me 5 volts on the top rail, and we've got 3 volts on the bottom rail. And so the 5 volt signal from the ESP will go through to the logic converter. It'll convert it to a 5 volt signal, which then goes into the intelligent RGBs. I'm running about 10 volts into this power supply, so this power supply is converting that into 5 on that rail, as I said, and 3 on this rail. So we've got 3 powering the ESP. And I've stuck this great big capacitor on there as well. See that massive capacitor? That's just to smooth the 5 volts. I'm running this from a bench power supply, and hopefully that'll stop any spikes coming through, and it'll also give a nice steady current when the LEDs are running through a sequence. The other one I've done is make some rainbow colours. click that, and we just fill it up with all the rainbow colours. That's simple. I haven't put an off button, just use one of these sliders here, and it'll turn, if they're all turned off, they're turned off. And also we're just using the one web page. It calls this picture, and that picture is on the ESP as well. And I've also put another web page, and I've put that so I can show you how we can actually go from one web page to another web page. So if I click this one, you can see we've got a nice little circle with the rainbow going round the circle, and this LED strip is emulating what's on the ring on the web page. This one here, this LED here, is the start. So if you watch, this is, well, we're coming from the breadboard, and it starts here at this one there. That's just lit up there, and then it goes around. And you'll notice that I've got this all in sync as well. So basically, when it comes around to this top red one, top LED, whatever colour it happens to be, you'll see it light up there basically, start, and that's actually in sync. And this number there just tells me I've got 30 LEDs. Well, that can, if you want a strip that's got longer or shorter LEDs, you can change this value in the code. So basically that just keeps going round and round the little rainbow. And to get back to the main screen, we just click the back to main button here, and that'll bring us back to our main button, where we can actually just do our adjustments and have it whatever colour we like. So yeah, so that's it. So I'll just knock all them off, and let's have a look at some of the code to do this. Right. Well, I use Microsoft Visual Studio Community Edition software because I find it has IntelliSense, which helps me do the coding. Now, I'll be putting this file on the Instructable. But first of all, what we need to do is, when I give you basically this header, if we look at the Arduino, when you open it up in Arduino, so if we open up this one, where I missed it, there we go. So if we open this one up, you'll see that there's a credentials header there. I'm not going to show you that because it's got my credentials in. So basically all there is in this header file is what I have where are we? I can't find it. Oh, here we go. I went past it. All we have in this credentials header is this here, which I've commented out. So basically, when you get this file, you just need to delete this thing, because I won't be supplying the credentials header. What's in the credentials header is these two lines. I'll just uncomment them. And you see these two lines here create the network name credentials. So you alter this to whatever your local network is, and in this one here you put the password to connect to your local network. So you delete this and you uncomment these two. I'm just going to put it back to normal. Well, how I have it at the moment, because I'm actually using this file which has got my network name and password in, so it's just so that I don't mistakenly show the whole world, and the whole world can come and connect to my computer. Right, so we've got that out of the way. Right, so the library basically is we're using is the ESP 8266. I got them numbers the wrong way around, haven't I? Anyways, not there, but elsewhere. I keep calling it a 2866, but it's 8266. And then we've got the web server, and we've got a file system on there. And to do the pixels, I'm using the Adafruit NeoPixel library as well. Now, because we're creating a server, the normal way to do to use the Adafruit library is to run write the code onto your Arduino to run samples. But if we was to do that when we're using a server, you see, in the loop here, all I have is the server handle client, and that is because we need the actual client to run any commands and sequences that we want the NeoPixels to do. So if we look at the where are we? LED strip. Not that one. Yeah, there we go. That's just the comments to tell you what we do. Oh yes, and I've put down 3 options. 3 options. Yes, here we go. Not that one. Yep, that one. Right, so there are 3 options, 3 ways of connecting. At the moment I've got this one, access point, and it's a station. So as a station it connects to the local Wi-Fi, and it uses these 2 credentials here. So it's using these 2 credentials to connect as a station. But of course mine are on the header file. There are other 2 ways to connect, so if we comment this one out and we do this one, well actually let's do the one with the password. So if we have that one commented out, what it's going to do, it's going to use these 2 credentials here. You can put any name you like in here. I've just put mine in, and the password is just 1 2 3 4 5 6 7 8. It's okay me showing you these because these are actually what goes onto the ESP 8266. So you're putting them onto the actual server on the ESP basically. So this can be anything, and you can try using them, but you're not going to connect to it. You're not going to connect to my ESP. This is just for your ESP only. And as I've stated before, this password needs to be at least 8 characters long. Otherwise it'll just ignore it and leave whatever password's on there, if there is one. I think I've written that something. So yes, so that would be that. And this is without a password. So if we're using this one here, just this one, then you don't need the password anyway, so you just need a name for it. And this is what will show up on, hang on, I'll just bring my test bar over so you can see it. And this is what will show up here. Hang on, I'll connect, it won't show it yet there yet. And as before, I'll just unplug it. As before, this is just what I use for Wi-Fi. One of these dongles. There we go. Yeah, this is to connect to Wi-Fi. But I'm also connected to the internet on my router as well, which is wired. So I'm on my PC, which is as a cable direct to my hub, so I can connect via Wi-Fi and a router. So let's go back to the software, hardware, firmware, whatever. Right, what I'll do is if we go to I'll do is we'll just do a change here, and I'll put this one, and we'll upload that to my ESP. Yeah. So the way we're going to connect now is we're going to actually connect to the ESP itself. What we're connecting to is, I'll remove that. There. We're going to connect to this ESP itself. The server is on here, and we actually connect direct to the server through Wi-Fi to the ESP. So I'm going to use. Can I get that in shot? Going to use this. All right. Anyway, so that was my local network, but now. Let's just bring up the code again. So if we bring up the code and we look in the code, there we go. We can see that these here, this is what I've set the IP address to on the actual server. So when we're actually using it as an access point, this is the address of the access point mode. So you can change this if you like. If you're going to do more than one, then basically just change this end number and go 10, 11 and 12, 13, and then you can connect to each one individually. So that is now the address we need to do. But first of all, let me just bring back up my tablet. Yep, I'll get that light out of the way. There we go. So if we bring down, not that one, the Wi-Fi. Yep, so Wi-Fi. So I'm on Tim's network now. But now you can see that we've got Tim's Wi-Fi RGB control, which is the name there. That's the name that we give it for the access point mode. So that's the name, and there you can see it on here. Now I've connected already, so what I want to do is oh right, yeah, I haven't connected this way on this, so it's asking for the password now. So all we do is type in this password that we put here. 1, 2, 3, 8, and then connect. And then we connect to the RGB. Now, because we're connecting from a device that has no internet, you know, if you're using a phone or anything, it may disconnect, and you'll probably have to go in this doesn't have it, but you would have to go in there and you would have to tell it that you want to stay connected. So we can now go back to the web page. And in the address bar, we can actually type this address here, which is this one. Oh. What was it? 5010. Press enter. Go. There we go. It's going to look exactly the same anyways. And so from here, let's just go get the big picture again. I'll just move this side. Oh, I've got the lighting way there. And so we can change it through our device. Oh, sorry, mic fell off. Yes. Right, where was I? Yes, so we can use it using this, but this way it's only this device is actually connected to the server on the thing. So what we'll do, I'll just turn it all off again, and I'll just shut this down. There we go. So what I'll do now is we'll put it back to, oh, I shouldn't have shut that down. We'll put it back to the local network. So I will put it back to as a station. So if we go, well, not do it there. We'll do it there. So what we'll do is I'll just re-comment that one. No, not that one. It's that one. Right, so, and what we'll do is I'll upload that to the ASP again. And what I will do, while it's doing that, I'll let it do all that. I'll bring back the well, no, I'll leave that there so you can actually see what's happening. Basically, these are the only things you need to change, really. Oh, and of course, this one here, these. So there we go, so it's resetting now. So basically, this server on here now, on the ASP, is now connected to my local network, and because we're on the local network, I'm just going to move this back to where I normally have it. Just need to resize it a little. There. I have another monitor, so I usually have my taskbar on the my start bar on another monitor, so, and I got used to it. Don't need that. No, what I'm looking for is this. Yeah, right, there we go. So, oh yes, I do need the Arduino. Right, okay, let's just bring the Arduino back. Right, the thing is, we're now in access point. You have no idea what the actual the IP address is. the IP address is allocated by your network. On your router there is a little bit of firmware that when you connect something to your local network, it assigns it an IP address. So what we need to do is find out what the IP address your network has assigned the ESP once you've connected through connected to your local network as an IP address, as a station. So you need your Arduino connected through your COM port, and you need to open up the serial monitor. So open up your serial monitor and we'll press the reset down here, where my finger is. There's a little reset button. So if I press the reset button, you'll see that the ESP is in station mode and it's now connecting. Once it's connected, it gives you the IP address that the network has given your ESP. So this is the number now that we're using. We're not using the number. We're not using this number because we're not connected as an access point. We're now connecting through this on the local network, and we're using this, and we're not using this either. This is not being used. It's using these credentials that you install here. Hang on, better on for you. You better. So we're now using these credentials because we're now connecting. We're now connected to your local network name. We're using your local network password that you enter into this code here. So to use these, we have it on the access point. And mine are obviously in the in this credential, so you can't see them. So yeah, so it's now giving you so the once the ESP has connected to your local network, it will the serial monitor through the USB prints out the IP address it's been allocated, which is what I've typed up here. So yeah, it's still the same as it was before. I'll just refresh that. There we go. And let's go back so that we can see what's happening. So if we now do that, now this web page can be on any device on your that is actually connected to your local network. So for example, I'll just bring back my tablet, and we'll open Chrome on here. And actually, see, that's what we were using before, and it's just got this out of cache, but it will do nothing because we're not actually connected. This is just in the cache of the browser. What we need to do is we need to change the address to there. You can see that I've done it before, that one there. So the 192.168.038, which is the same as the one up here. So I'll just select that one, and there it's come back on that one. So what we can do is I can change the colour on here. There we go, it's lit. And I can also change the colour here and here, so like that. So we can use this one, control it on one machine. This is on my computer, and we can control it on this laptop. This is because both my tablet and my PC is connected to the local network, so whatever is on the local network can actually control the server on the ESP. So now I'll shut this off because I've shown you that. So I've done with my tablet, and I'll just turn everything off on here. There. So I hope that was helpful. Let's get back to the code. So inside my code, we've gone through these as an access point and as a station. So depending which one you're going to use, you'll either use these for the access point, or you will use these for the station. And obviously this is for the access point, but as a station you get allocated these IP address from your router, so you need to open up the serial, or if you leave this thing connected as well, there's this I've put some feedback so you can see what's happening. You can see that we've got the error 404 not found. That was when we were using the tablet on the wrong IP address. So I hope the configuration and the connection is all sorted and done. We'll now get back to the Adafruit library. Alright, in setup, no, in configuration. Right, here we go. Right, so the Adafruit library, right, at the moment, I'll just bring this back. The LEDs that I'm using, there are many types of LED strips out there on the internet, different voltages and different ways of communicating. And there is the red RGBs, which red, green and blue, and there's RGBW, which is the red, green and blue with a true white, and they're slightly different. I'm just using the RGB. So with the Adafruit library, you can have different configurations. So when you create this, at the moment I've got the Adafruit. I'm creating an instance of the Adafruit LED library. I've called it LED Strip, and I've told it the number of LEDs, which is this one here, 30. So if you have a strip with different number of LEDs, you can change this value, so it knows what value of what number of LEDs are on your strip. This is the pin number, and I've actually got it on pin number 5 on the ESP. Right, now then, actually I just need to find that. I forgot to get this ready. Where did I put it? Yeah, on the ESP, the numbering, it's got some D numbers there. Just ignore them numbers. You need to have find yourself a chart. Well, here we go. Right, yes. These D values, but these D numbers on here are nothing to do with the Arduino RDE I've put the D numbers. So when I say I'm on pin number 5, I am actually on D3, which is no, where am I? I'm actually on D1. So D1 is the Arduino pin 5, which is the actual GPIO 5, the general purpose in and out pin 5, which is D1. So this is the actual number that we need to put in here, which is D5. If you want to use one of these other numbers, you'll need to change, one of these other D numbers, you'll have to change it to whatever I've written here. I'd be aware of the ones in red. The red also have special purposes, and it's best to leave them to last and use the others. You can use these, but you need to know what else happens with them as well. So that's I'll minimize that this time. So yeah, that's the pin 5 and there. But you can see I've written in here that you can have the pin number, you can have the data pin, and you can have this pixel flag plus pixel flag. So if you're using the pixels that are wired for red, green, blue and white here, then you can add these flags in. What you would do is you would put that there, and oh no, you wouldn't. You do plus, and you'd put this. It's probably this speed here. So you would write it like that. There we go. So this is all one value. So you're using one of these plus one of these, and you would write it like that. Well, actually, if I went for that one there is pretty much the same as that. It will just accept two variables. So yes, the Adafruit library is it caters for a lot of different LEDs. You best go into Adafruit's site. Did I put that in there? In credits. Oh no, I should put the actual site to the information. Anyway, yes. So if we look at our pixel, there you can see all the different variables you can use. Hang on, not that one. Oh, that's it, LED strip. Right, so if we look at the LED strip, best to look at it where I've actually put it. Oh, let's go down here. Right, let's just type a new instance, and then we can see. We can see it's got the begin command, can show, clear, all this. We can use all these variables, but we don't want to run them direct from a subroutine. So what we can do is if I was to put that in there so that it shows whatever pixels, then we go LED show. We copy this one, and so every time it looped it would go into this function here, LED strip show, and then show the LEDs. What would happen, this server would time out and it would disconnect because we're out running in this function here. So we don't do that. What we now have to do is treat this loop the same way we would do treat an interrupt. We would only put any things that actually change values, some preset variables, but we would not actually run any routines. So we can't do that, otherwise the server is going to time out and disconnect. So we have to do everything through the server. So to do everything through the server, we need a web page. So here's my web page. Well, actually, let's just have a look at that. Well, we've seen the web page. That looks like it looks like that. This is just showing me how roughly how to edit it. But we have to run it through this, and what we do is we run code. So every time I move this slider and turn on the LEDs like that, it is the web page telling the server to do things, and we're not doing things ourselves. So what we have is we have the same commands here. So the server will look for things like LED show, LED set pixel, and then it will then run the subroutine. So if we look at these let's have a look. So we can set color. So if it receives a command to set color, it will go to the handle set pixel routine, which is here. So we create our subroutines to do things, but we call them from the web page. So we call the subroutines from the web page. We don't put them in a loop or in anything like this. Basically what we're doing is we're going through the server to do this. Basically we send a command from the web, it goes to the server calls this command, and then we can actually get the value we sent, which is this. This command is what I've done is, because the way servers and web pages work, everything is sent as text. So you have to create some sort of rules. And so if we want to have a look at this web page, and we look at what happens when we move this slider. This slider creates a different value. You can see the value there. It's now at 116, and then we turn it down to 0 again. We want that value to be sent to the server, but we can't send it as an integer. We have to send it as text. So let's have a look at some of that code. I'll just put it down to source here. So if we look at our web page, I've made this is actually a table, and I put these all into different cells so it makes it nice and hunky-dory. And if we look at the red slide, so if we go is that the red? Yep, there's the red slide. We can set that to a min and a max of 255, because that's the values that I want to do, and currently when the page opens the value is 0. But when I change this slider, this value will change to, say, 84, and then I want to send this on. So what happens is on input, that's what we're doing here. We're inputting a value. So every time I'm moving this, it's like typing 120 into a text box, but we're doing it the way of a slider. It looks cool, and we don't have to do any typing. We just slide it, and basically what this is doing is writing 146 inside an input box. If we look at the split, you can see these are the values. You can see that one there's 200 for the brightness. So that's all it's doing is creating a value. When you move that, it's giving a value. And so what we want to do is, once we've moved that, we want to run this command here with whatever value this slide has. So this is all done with JavaScript. So let's go down to JavaScript and let's have a look and find that. There we go. So we'll look down. So there's our function slide move and the element that we've done. And so we look to see if it's the red slider or the green slider, the blue slider or the brightness slider. In this fact, this happens to be the red slider. So it will use the ID, because I've given this red slider the ID of red slider. So we get the red value, which is that element's value. And then I get the HTML, the part of the document that is the HTML side, and I give it a value of red. So what this line is doing here is changing this here, that. So that there, I've given that an ID of red value. So this is looking at the document, the whole document, gets that element ID, and it changes the HTML value, the inner HTML, which is the inner text, and it changes it to the red value, which we got from the element value here, which we created. So now we have a variable which I've defined previously. Where are we? Let's go to the top. Red value there. So in JavaScript we define a value by let. It used to be sometimes well, there's two ways. You can have var as a variable, or now we're using let, because it's moved on a bit since I started. So we've got a red value. So every time I move this slider, that's what happens. It changes that value there. It moves it up. But when I let go, I want it to do something else. I want it to send a command. So when I let go of the thing, it will change the LEDs. So if we look at the HTML for this slider, which was the red one, there's the ID, red slider, and you can see when the input changes, we went to slide move, but when it could be on a phone, so we need to have the touch end. So when I finish touching that slider, or if it's on a computer, it's when the mouse goes up, that means when I've let go of the slider with the mouse, we go to this function. So basically we've got two functions here, depending on what we do with the slider. If we're moving it with a touch on a phone, or we stop moving it with the touch with the mouse, and if the slider actually changes its value. So we've looked at this one already, so now let's look at this one here. So the slider moves. This one, when we went to this one, it actually set that value, remember, of the red value. So we can use that because we've altered that in this first movement. Then when we let go, well, let's stick with red. When we let go, we go to this function. So in this function, the slider color set, I'll come back to that. But we now set this color, which is another variable that we're using, which is if I highlight that and go up there. This is another global variable. We run this function, which we get this colour from adding a red value, a green value, and a blue value together. What the Adafruit library can see is a sum. So we're going to, what we'd have to do is we can create all them values to a 32-bit value, and then we need to use the LED value. Oh, well, actually, I'll just show you this one. So basically, in here we have a function. There we go. This one. So our function color to unsigned integer 32 value. We send the red, green, and blue, because we've also set the global values of all red, green, and blue. It takes this value the same way as it took the red value, and it takes the blue value the same way it took the red value. Except it stores it obviously in different variables. So it gets them, and it's just this simple little sequence. It takes the red and it moves all them inside the 32-bit value, 16 bits to the left. Takes the green, moves all them values 8 bits to the left, and it leaves blue's value where it is. So you end up with a 32-bit value that's holding only holding all the colours, basically. What you've got to do is imagine these as, I put it somewhere. Yeah, here we go. That's straight on it there. Look. You've got to imagine all these colours as a binary. It's put the red here, it's put the green here, and it's put the blue there. This is for in case there is an LED with red, green, blue, and also a true white. But we're not actually using this value. But it's the LED colour is unsigned integer 32-bit, because that is what the Adafruit library uses. So let's just go back to the index. Where was I? Oh yes. So once we've changed the current colour settings into a 32-bit value, we send that 32-bit value to LED fill, which is here. So what we do is we create a new XML HTTP request. That's when you create a new one of these, and which is called LED fill, and it has a value of whatever we created here, but it's in text. That value is a text value. It'll send it as text. Right, there we go. Colour, yeah, because that's what we send to it, and then it waits for a response, and then once it gets that response, we then send another command, LED show, which is here, LED show, which is another HTTP request, another one of them, and we send the command LED show and wait for the thing. But you'll notice that you'll notice that I've put this in a timeout. When we send this fill command, which is this fill command up here, which is this one, this request, it takes time for the web page to the server and the server to run that command. It takes a little bit of time, so we can't send this one straight after this one. What we want to do is we want to delay the sending of this one slightly by 10 milliseconds. So I'm going to wait 10 milliseconds. That's what this timeout is. Basically what the timeout does is it says wait 10 milliseconds, then send the LED show command. So that's basically how we actually send commands. All the others are just variations of the same thing. And so if we look at the server side of things, so if we're sending a, let's just say the show command, let's go back to that there. So we send this show command, which is basically this /show. Now, what this is actually doing is the same as, right, okay, let's just do this manually just so you know what's going on. Let's just put that to 0. And anyway, I'm just going to bring up the monitor. Right. So this values here, this values dot. This is the val. This is what it's sent, or could have sent. It's a 32-bit value. This is a 32-bit value. So if I just copy that, and what we'll do is, so if we go to the LED set, no, that's position. Let's do the whole LEDs. What was it? Oh yeah, the LED fill. Right, the LED fill and a value. So as I say, when we move this slider up there like that, it moves the slider, it changes the colour of the LEDs. And what it's doing is sending this command and a value. So if I turn that off, and what I can do is, actually, what I'll do is I'll copy that first. Copy that, and I'll just expand this so we can see what we're doing. So what that function is actually doing is, like I say, it's all text. So if I send that and that, and put that in there, right? If I send that now, and I just press enter, right, that's what it's actually sent, and we get a reply of OK. So this, where are we? Let's go back to the slider. Right, so I've sent this part so far. I've sent LED fill colour. So LED fill, not yeah. So I've sent this LED fill and the colour. Oh, that's the third one. Hang about. There, I've sent that, the LED fill and a colour, right? So basically what I've just sent is this, there, and that colour. So I sent that, and then this XR response text here is this. There, it's just sent back. Okay, yeah, I received that. Everything's fine, hunky-dory. So if I go back to this, where our slider moves and we set the next command, we need to show what we've just told it to do. The first command actually just changes things, and now we want to show what we've changed. So this set timeout sends this command 10 milliseconds later. Well, it's been more than 10 it's been more than 10 milliseconds, but anyway, it's after the point, after the thing. So what it does, it sends this. So if I copy that, so if I now send that, so what we'll do is that, and I press enter now, it will update the LEDs with the colour I've just set. There, that's it. It's that simple. All the web page is doing is sending it's sending this and this, because it's sending this so that it knows it's talking to the correct server, because it's talking to whatever server is at this address, and it's sending this command. So if we look at that command, it's now updated in. If I now go back and let's do that again, and it's sent a reply OK. So if we go back, let's have a look. We'll do this one. We'll do the send clear command, right? Okay. So basically, all this function does is, I lost it. All this function does is send that. So I will send that to the server. I press enter. It's come back OK. It received that. But again, of course, we need to update it. We need to is it in memory? Oh yeah, there it is. It's in memory. So if I click this one, it now clears it all, because the LED shows you've got to send two commands. You've got to send a command to set what you want, and then you've got to send a command that shows what you've told the LEDs to do. And we get an OK again. Everything's hunky-dory fine. And if I just want to go back to the old web page, you see it's just got a /. That is a command in itself, and I send that, and we're back to the original web page. It defaults to the index. I've called this page index, and that's where it defaults to on a thing. We'll move to that in a minute. Right, so hopefully I've shown what we need to. This is all. It looks complicated, but all it is you're telling it to do that. You're just telling it to send a command, and then when we get to the actual server, which is the UNO part of it, what it does is when you're sending those commands, so the server here is looking for these commands. You can see it's looking for an LED show, and it's looking for a fill, and there's some other things we can also. The slider button will send a slider set brightness command instead of the set fill. So you have here what you want the server to look for, and then you have the function you want the server to run once it receives one of those commands. Now with this with this ESP, you can also save files on the file system, which is a tongue twister for me. Where are we? Well, it's a file system, but let's just minimize a lot. We've been all through all that, so make things easy to find. We've done that. Start up. Right, yeah. We also have, well, I'm going to call it spiffs. Right, spiffs, because I can't get me. It's the Serial Peripheral Interface Flash Filing System. Right, from now on, spiffs. Right, so we have the spiffs where we can store actual files, and on this actual ignore all this and these two. Oops, ignore them too. That's just that's something I haven't got running at the moment. But with this, I've got my credentials, which you don't need, but you have a folder called data. So inside data, I've actually got the index file, the index HTML file. I've got the Intelligent RGB LED, which is this picture here, and I've got the LED chase. So that this chase is the other rainbow chase is the other web pages, which is this one. Can we see that running? Yeah, there you go. See it running there. And then we go back, and this is the actual index HTML. They're actual HTML files, so you can store them as HTML files. Unlike before, when I saved them in a header, I'm now saving them to the spiffs. And to get them from the spiff, the ESP, the ESP whatever, has this command, which can get us a static file from the spiff. Yeah, so spiffs. So I've got my web page, I've got my image file, and got my web page for the LED chase. So I've defined these up here. Basically, all I've done for these is I've just set the address. They're actually in the root folder of the folder data. So the / and the name of the file. That's it. If you want to put another subfolder in here, like that, say a new folder, right? Up here, and put files in that folder, you would put it like that, and put things in that folder. It's best to have no spaces though with names. It saves a lot of hassle sometimes. So that's how you would put things into a folder inside your data folder. So we'll forget that, delete that. At the moment, it's just best to keep them in straightforward data folder, and then you're in the root, and that's its name. So that's what I've defined these are. So if you look down there, you can see there I've defined it. It's index HTML. So you can actually just put that as. Let's get that. If you wanted that web page there, could be didn't copy it. There. It could be just written like that, but I've defined them first, and then it makes it easy for me to makes it easier for me to put them in. I can see exactly what they are, basically, and you just tell it that it is this. See, at the web page, you need to tell it it's just a text HTML. But with an image file, you need to tell it it's an image file and to what format the file is in. So this image file there is a PNG file. So you in this argument, in this call, you tell it it's an image and it's in the PNG format. If it was a GIF, if this image file happened to be a GIF, then you would say it was an image, and you would tell it was a GIF in there, basically. So that's it. And what happens is this server will call this web page and send it back. Well, send this file back to the client, which is your web page, when it sees this command, or if it's when the web page opens. I'll come back to this in a moment. This image, when this web page is opening up, at one point it will ask the server for this image, and so when it asks for this image, you will tell it you want where the image is, and basically you tell it it's on the server and it's called my image. So when the server sees this command, my image, I'll tell you what, let's just show you. I'll copy that, and if we go to here, and as before, if I was to, oh, hang on, wrong, done that. If, as before, if I just send that command from the web page to the server, what the server will do will send me that image. So I'll just press enter. And there you go. I've just received the image. That's what this command does there. So when the server sees this image command, it will look on the SPIF for this image file and send that image as a ping, and that's what it just did. There we go. Let's go back to our main page, and the same again for this. So if I send the command rainbow chase, right, so when I click this button, it goes to this new web page, rainbow chase. Let's go back. But if I was to send it manually, there we go, that rainbow chase. If I press enter now, exactly the same thing. That's all it's doing. So, right. So this is sending files from the SPIF. This is calling commands to do something, basically, which you put into a function. As I say, if we look at go back to the web page now, and we want to have a look. Let's just have a look at this. So the rainbow chase is slightly different. So if we look at that rainbow chase there, it calls this command. When we click that button, it's going to call that command there. So let's just have a look at that and go to that next command. Back to just have source. If we wanted to bring another web page, it is this command there. So it's sending this command because that's the command the server sees, and it will send the web page. But what we want it to do is we want the window being the web page, we want the window location to be a new web page. The location is a different web page to this, basically. So it's this command, and this makes it a new web page. If we did something like this, if we did something like this with this command, all it would do would fill this page with the web page, and that is wrong, because it wouldn't do nothing. It would just fill it up with the actual page. It wouldn't be an actual separate web page. To make it an actual separate web page, you need to use this command. Well, this command and whatever you've called your web page. So, and then if we go back, if we look at the rainbow cage, and that's the similar thing I've done with this button here. So if we look at our web page for the, hang haven't got that split, but if we look at the button, there we go, it's just got the button. This is the page, basically. It's just got a button and a ring on it. Let's have a look at this in viewing web page. That's all it's got. It's got this ring, button, and a bit of text there. It's default one, but that just tells us. I just put that in just so I can check that I've got the right number of LEDs. So all the rest of it is done in JavaScript. So all we have on this page is the ring. There's the ring, and we have the button. There's the button. That's all that's there. The rest is done in JavaScript. But if we was to press this button, it goes there, go to index. It uses that function there. So if we look at that, and there's a bit more in this, but basically we've got that Windows command there, which is just this / which is what our index is. If we look in here, we can just see we've got this command there, just a / and it loads that web page, which is our index web page. But this, because if we look at it, not that one, we actually look at the real one, we've got JavaScript running and it's moving all these LEDs. When I go back to the main page, I want it to stop running this JavaScript. I want to make sure that's not running. It's not calling any commands to the server. And then once it's all ready to do that, then it goes back to the main page. So all this is doing is that bit there is just calling the clear and show. It's just so when you go back to the main page, it clears the LEDs, and the LED chase subroutine has stopped running, and just a bit of time to stop doing all that. But while I'm on this LED chase, I cheated. I really cheated doing this. Let's just have a look at this again. I cheated with that there. It's to getting all these little LEDs to run around there, getting them all located in web page. It looks really, really simple. There's not much code to it. That is it. That's just showing all the styles. It's telling you what colours and what size to make the LEDs and everything. And then there's the web page. That's it. It couldn't be any simple. If I had wrote this, it would have been a lot longer, and I'd have been pulling my hair out. This, that from here? Well, no, from here up to here was done by Bing Chat. Anyway, let's just go to. I'll just put hello. If I go to Bing Chat and I say there we go. Oh, hang on, I've spelled you wrong. Yeah, so you just do something like that. Can you show me an example of HTML code to show a circle of LEDs, of 30 LEDs, like that? there. How hard was that? Eh? Hang on, let's just bring up a text document. I'll leave it as text as a minute. Right, so I'll open that up. There it is in Notepad. Copy that, paste it there, save. Change that to HTML. And open it up. Well, actually, I think it's thought that I wanted a circle and 30 LEDs in there. It's not quite come out right, but my original one I did, and it brought it out perfect. Basically, with you just say once you've got the start there, you just continue with it. Maybe I should have put 30 number. You've got to be. Oh, hang about. There's also. Right, hang on. Damn. There used to be a certain. Right. Let's just start fresh. Right. Oh, I was on precise. Let's go. Oh, no, I can't go back. Hang on. Chat. There we go. Go back to that one. Yeah, let's try again. Let's put. The more info you give it, the better the results. Right, let's just edit this one. It even tells you what it is. So basically, you can ask it about my code if you want. And let's see what this does. Ah, well, it's different. Let's just try go back. Oh, I don't want that one. Just tell it. Let's try. Oh, let's be more precise. like I say, I'm just going to start just to make the initial page, and then I started adding all the code in afterwards. All this function to send commands and everything came later. Let's see what that is. Oh, still the same thing anyways. But I just wanted to show you that some things can be done. It did actually write all that for me. It did the most of the hard work and simplified things. So I think I'll explain the rest in the actual in the actual Instructable. I'm not sure if I've forgotten something. I'm sure there is. Oh yes, of course there is. Right, yes. In the Arduino IDE, you also need to install the ESP sketch data upload. So what this does, this is a add-on which I'll give information in the Instructable, but this is what actually uploads the files inside the data folder. And also when you first start to upload, there is this option here. At the moment I've just got it on sketch only, but when you first start you may want to select all flash contents, so you're starting with a clean slate, and then go back to only sketch after that. Otherwise, once you've uploaded all this data, it will remove it all until you actually upload it again using this utility here. Well, I hope you found some of that information helpful. It was a bit long, but I wanted to go into more information about the software on the video, rather than just type it out, really. It's just sometimes seeing it on a video helps you actually see it better and see what's going on. I will do a fritzing of this setup of how I've got everything wired together on the Instructable. But I hope you found that interesting. If you made it to this end, thanks very much. Thanks for watching, and see you next time.